Hi, Assalamualaikum. We meet again in our online class. Okay, we will continue our lecture about the transmitter. Okay, now we will discuss about the transmitter topology. Okay, transmitter topology. Yeah? So what is that? It is the components uh, setup in order to design a transmitter. Okay, so the figure at the right shows the block diagram of some typical transmitters. So we have uh, first we have high level modulation. Okay, so second we have low level modulation of synthesizer. Okay, so for AM we are using this high level modulation, and this one will be used in the next part of this subject for PM and FSK. There are many varieties of transmitters, but most are based upon these structures. So there are many types of transmitter, many type of application of the transmitter, but basically the topology is just like this. Either this one or for high level and this one for low level. So what are these? So first we have here frequency synthesizer. Okay, next is buffer, next is frequency multiplier, and then you have driver, then you have a power amplifier or modulator, and then here this is the modulator, right? And then you have baseband signal input. This is the input signal, and here we have baseband signal processing unit, and the output is the matching circuit. Go into the matching circuit, and after that you have antenna for transmission. So all these components is the building block of a transmitter. So here let's see low level modulation synthesizer here. What is the difference? The first part is baseband signal input, baseband signal processing, and then you have frequency synthesizer or modulator, then you have buffer, frequency multiplier, driver, power amplifier, matching circuit, and antenna. Okay, so what is the difference? Difference is this part. Okay, this baseband signal processing. The first part is in the middle of the diagram. Okay, and the second part here for low level modulation, this part baseband signal processing and baseband signal input is at the beginning of the block of the diagram. Okay, next. Okay, there is the video Watch the clip video and answer the question that follows. Okay, you can click this on your PDF notes. Okay, using Adobe maybe, so that you can access this link. You can click this link and you can watch the basic about the AM transmitter. I think this is about 7 minutes. Okay, you can watch this later. It is quite interesting video. It's not by me, but it is external video from somewhere else. Okay, but it is discussing about the basic for um, block diagram, the basic for AM transmitter. Okay, so after watching this video, you can sketch what is AM transmitter and explain the purpose of each component. Okay, so there are full carrier AM transmitter. AM transmitter are already mature technology, but they are still in widespread use. Example include standard AM broadcast station. Okay, this is radio. Second is CB radio in 27 megahertz. This is a citizen band. So again, if you don't know what is citizen band radio, you can Google. Okay, this is called I think it is radio amateur, where the citizen can communicate among them. Whoever has this set of radio, CB radio, so they can communicate among them for certain use. Okay, like for disaster, for certain for hobby, for example, right? So you can go Google and see what is this. Okay, the next is VHF aircraft radio, very high frequency aircraft radio. Same, if you want to know further, then you can research on your own. When modulation is accomplished at the output of large stage in transmitter, it is referred as high level modulation. Anything else is low level modulation and is much less efficient. Okay, this is the block diagram for transmitter for full carrier AM. Okay, first we have a frequency synthesizer. The main function for frequency synthesizer is basically to generate or to produce the carrier frequency, to produce the carrier signal, FC. Okay, then we have the buffer and frequency multiplier. This frequency multiplier is used if the modulator here need a higher frequency carrier. So they multiply this the frequency from the synthesizer, multiply here, and then you will get higher FC. Okay. Okay, you have the driver, power amplifier or modulator. So here, the modulator. Normally we say that this is the modulator where you have FC coming as the input, and then this is the baseband. So baseband is FM. So this is where the modulation process happen, where FC mix or plus with the FM. So baseband signal input go through baseband signal processing before it goes into modulator or power amplifier. Then the output from this modulator will go to the matching circuit and then being transmitted using antenna. So this is a high level modulation which already shown in previous slide. Okay, so for transmitter full carrier AM, full carrier means it has carrier, double sideband. Okay, you have this carrier oscillator. This is for this is a baseband input signal processing, baseband signal processing, and then carrier oscillator here. The modulator is here. Okay, so this is the FC and this is the FM. Okay, then it goes into the mixer where the signal frequency coming again, mixer here, band pass filter. This band pass filter is, the function is to eliminate undesired mixing component, and then goes into the driver and then power amplifier, matching circuit, and then transmitted using the antenna for the transmission. Okay, this is the heterodyne system for PSK, QAM, SS, BSC, AM. Okay, this is used when need to modulate signal at fixed frequency. AM transmitter stage. All of the stages of the transmitter, except the power amplifier and possibly the driver, operate at low power levels. This part of the transmitter, exclusive of the power handling stages, is called exciter. Okay. Other transmitter components include oscillator stage. So this is the transmitter components. Okay. Other transmitter components include oscillator stage, buffer and multiplier stage, driver stage, and power amplifier or modulator. This is the components of transmitter, components of the transmitter, or the building block of the transmitter. Output impedance matching. Most practical transmitters are designed to operate into a 50 ohm resistive load. 50 ohm resistive load to match the impedance of the coaxial cable that is used to carry the power to the transmitter. So there is a coaxial cable. Oops, sorry. That is used to carry the power of the transmitter. Transmitter output circuitry must be designed to transform the standard load resistance at the output terminal to whatever is required by the active device or devices. So normally this is called resistive load. Okay. Oh, mana ada problem ni. So it is normal that you have RL in the question. Normally you have RL equal to 50 ohm or 100 ohm. So this is the load, the resistive load is around this area, very low resistance, to match the impedance of the coaxial cable. To match the impedance of coaxial cable that is used to carry the power to the transmitter. So this is where in the question normally you see the RL given is in this range, 50 ohm, 100 ohm, and so on. Okay. Modern AM transmitter design AM transmitters have been built since the invention of the vacuum tube, and their design has changed little since then. There are some new approaches that are now in use. High power AM transmitters are large and expensive because of the power handled. Recent efforts to improve AM transmitter include the development of high power solid state power amplifier. Apa benda ni? So high power solid state power amplifier and the use of pulse duration modulation and switching amplifiers in the modulation process. Okay, so now modern technology use solid state RF power amplifier, pulse duration modulators, digital amplitude modulation. Okay, so these three are modern AM technologies. So what are these? If you want to know further, then you can search yourself. Okay, so here is the change in the topology of the transmitter by using modern technology. Okay, now you have audio input. So audio input is a baseband signal. Okay, now it goes into pulse duration modulator, optical coupler, switching amplifier, filter. Okay, so you have the transmitter. The topology is slightly different compared to the previous transmitter block diagram. This is the modern technology where it use these three modern components: solid state power amplifier, pulse duration modulator, and digital amplitude modulation. Okay. Next, we have single sideband AM transmitter. A typical single sideband AM transmitter block diagram is illustrated below. This is single sideband. You still remember single sideband SSB? After remove, the original AM signal has two sideband, double sideband. Okay, so when you remove one sideband, then you have single sideband. So this is the block diagram of the single sideband AM transmitter. Okay, so here we have carrier oscillator, then buffer, then balance modulator, where the audio or the baseband is input. Okay, then it goes to crystal filter, RF amplifier, the mixer. Here they are using this is here double sideband suppressed carrier is generated, and then here they remove one sideband. Okay, remove one sideband here, and then at the mixer, mixing with operating frequency. Okay, frequency from frequency synthesizer, and then here it goes into BPF. This is a band pass filter. So where it remove one of the sideband, and driver and power amplifier, and then transmit at the antenna. So normally, how they remove the sideband? Using band pass filter. Remove one part of the signal of the sideband. Okay. So this is the balance modulator for double sideband suppressed carrier generation. Balance modulator is the component that used to provide to produce a suppressed carrier signal. So balance modulator are used for double sideband suppressed carrier generation. The output of a balanced modulator is shown here. So here you have a sine wave and the baseband. This is the carrier FC. This is FM. Okay, so this is the balance modulator. So the output of the balance modulator is shown. Double sideband suppressed carrier. Yeah. Generating single sideband signal. Bandpass filters may be used to filter out unwanted sideband in an AM transmitter. So how we generate a single sideband? Meaning that normal AM signal have USB and LSB. Okay, remember upper sideband and lower sideband. So there are modulation that produce a single sideband, right? Single. So you need to remove one of these. Either you remove upper sideband or you remove lower sideband. So band pass filter may be used to filter out, remove unwanted sideband. One of the sideband in an AM transmitter. The carrier is not filtered because its large amplitude and proximity to the desired sideband. The carrier is typically null with a balanced modulator, and then one of the sideband is filtered. So you can remove the carrier as well using balanced modulator, and then remove one of the sideband using band pass filter. Okay, so single sideband generation, carrier oscillator, balance modulator, audio amplifier. This is mic. Mic is the input for baseband signal, your voice. Baseband FM. Okay, this is FC. So here, this is double sideband suppressed carrier. There is no carrier here. And then using band pass filter, you remove one of these sideband. Okay, so here the first here is band pass filter. You have this the band pass cover from which remove the lower sideband. So the result is only the output is only you have upper sideband signal. Okay, you have single sideband signal. This is upper. This is upper sideband. On the other hand, you can also remove the upper sideband by using the maybe high pass, band pass filter, but remove the higher frequency from this one. Here is FC plus FM, right? So this band pass filter remove the frequency between this upper sideband frequency to carrier frequency. So remove this part. So what is left is lower sideband only. So you have for the single sideband signal, you may have upper sideband or lower sideband. Okay, so if you have upper sideband, meaning that the band pass filter remove lower sideband. Okay, and in the other hand, if you have the lower sideband, it means that here in the band pass filter, it remove the upper sideband. Okay. Mixer. Mixing in the double sideband suppressed carrier AM transmitter is done by carrier oscillator and a balanced modulator as shown below. So here is the balanced modulator. So now you have here upper sideband at 8.9 megahertz, lower sideband at 9 megahertz. Okay, so goes through carrier oscillator, buffer, balance modulator, crystal filter, okay, mixer, frequency synthesizer, and then again band pass filter, driver, power amplifier, and the output is at the antenna. Okay, power amplification. The last one is about power amplification. Power amplification in single sideband transmitter must be linear. Okay, so power amplification must be linear. Single sideband typically use much lower power levels than are found in commercial AM broadcast transmitter, as SSB is usually used for point-to-point communication. Okay, that's all for this part. So we will continue the last part of the chapter 2 after this, the next video. So that's all. So hope you can understand a little bit about this topic. So thank you very much. Okay, bye-bye.